Hello. Today we're gonna talk section 11.7, surface area and volume of cones. So first, our objective for this lesson is we're going to find surface area and the volume of a right cone. Okay, we've already had a few problems where it asked you to find the surface area. And again, for a reminder, when I'm talking about the surface area, I'm talking about the area of all the surfaces. So down here in the corner, I have a hexagonal prism. The base is a hexagon, so that means this top base is also a hexagon. And so if I'm trying to find the surface area of this, basically what we need to do is we need to find the area of this hexagon on the bottom, and then I had two of them, hexagon at the top. So I would need to find the area of the two bases. So I'd need to find the area of that base and that base, which if I find one, it would be the same, so just multiply by 2 there. But then I'd also need to find the area of all of the rectangles on the side. So that rectangle, and then this rectangle, and then the one in back, the one back here, and then the one back here, and then the one back here. So find the area of all those rectangles and add them up. So we actually have a name for that area on all the sides. Okay, lateral, the word lateral means side. So if I'm looking at a lateral surface, I'm looking for those side surfaces. Also, we just think of it, it's not the base. Okay, not the bases, but those sides. Okay, so in a prism, it's kind of nice because all of our sides are nice rectangles. So it's pretty easy to find the areas of those shapes because it's all a rectangle. So we would find the area of the hexagon, which we know how to do that. We'd find the area of those rectangles. We know how to find that and add them all up together. Okay. On a pyramid, again, we would find the area of the base. This one's a square pyramid. So I'd find the area of the base down here. So I'd find the area of this guy down here. Okay. That base, and then we find the area of the sides. Again, though, that lateral area, that side. So this side here, if you can see, there's a triangle, and then I'd have a triangle here, and then a triangle in back, and then a triangle back over here. So then we'd again have those lateral surfaces. Again, the side surfaces, not the bases. The lateral surfaces are triangles. So it's fairly easy to find the area of that triangle. But when we're talking about a cone, we can find the area of this base. That's just a circle. This guy's just a circle. Okay, but what about the lateral? What about the sides? What about this guy? What's that shape going to be? Okay, so I have it for you. It's going to look like that guy. Let's shrink it up. Okay, that is actually what a cone looks like if we unfold it. What we call that is a net. When we unfold our shape, okay, when we unfold our shape there, okay, we call that guy a net. So like a net for, a net for these shapes down here, for like this guy would be again, a square with then triangles all connected to make the side. Here we'd have a hexagon within rectangles. Okay, so here's the net. So if you can see here, we need to find the area of this circle. Well, that's just pi r squared. But then we need to find the area of this piece here, which if you notice, it's part of a circle. It's part of a circle with a radius of this guy here. There's our radius. But that radius is what we call is the same thing as right there. That's what we call our slant height. It's not the height, because remember the height is that straight up and down perpendicular to the middle right there. Okay, it's our slant height. It's the height of that side, but that becomes the radius of that circle. Okay, this length here is part of the circumference. Okay, and so basically we're looking at the area of part of a circle. Okay, and so we break that formula down into now this surface area formula. So basically where this comes from is here. Okay, so here I would take this pi r squared. That's just the area of the base. That's that big B, that base area. So that's again, just the area of the base over here. So it's the area of this base circle, pi r squared. And then this guy here, let's undo that. So then now to do the lateral, this is the lateral area, and it would be pi r times L, where L is that slant height. Okay, so it's basically just the unfolded of that circle. So again, we take pi r squared, again, that's just the area of that base, times pi r L. L is the slant height. Okay. Again, this is for a right cone, meaning it's a nice, meaning your height right here, this nice perpendicular, is right down in the middle. It's not skewed or tilted over in any way. It's just that nice right cone. Okay. So now let's find the surface area of a right cone. So my surface area, again, we denote that S for surface area. So my surface area is going to equal the area of the base, pi r squared, okay, plus the slant area, which is pi, the lateral surface area, which is pi RL. If you notice, we don't really care about the height of this cone. We really don't care about this height right here inside, that plain old height. We don't really care because it doesn't have, the slant height takes that into consideration. Okay. All right, so let's go ahead and let's do pi RL. So we would take pi times my radius of my base, which is 4 squared, plus pi times my radius, which is 4, times my slant height, which is 6. So you have 4 squared, which is 16 times pi. So we're going to write that as 16 pi, plus 4 times 6 is 24 pi. So now these are like terms. They're both pi's. 16 pi plus 24 pi. 6 and 4 is 10. 2, 3. So we'd have 40 pi. And this is, again, area, so that's square units. So 40 pi square inches, which is approximately, calculators out. Oh, I don't have a calculator out. 125.66 square inches. Okay, so 125.66 square inches. Okay, now the volume of a cone. A cone is very similar to a pyramid, except, again, it's not a polyhedron. Its base is a circle, not a polygon, but it's still that same idea of 1/3. If you remember our pyramid from our previous section, the pyramid volume is 1/3 of the prism volume. Same with a cone. So a cone volume is 1/3 of the cylinder volume. So again, 1/3, I just always remember this, 1/3 big BH, because that's the same as for a pyramid, so it's one less thing to remember. But in this case, our base is a circle, so the area of that base we could write here as pi r squared, because that's just the area of a circle. Okay, but I don't like to remember more equations than I have to, so I just remember this one, that 1/3 big BH. Okay, so where again, big B, have to make sure big B is the base area. Big B here is the area of the base. H is the height of the cone. This is the height of the cone. Word of caution here, it's not the slant height. It's not the slant height. Again, slant height is very different. The slant height is this distance right here. We denote that with an L for slant height. That's our slant height, not our height. For height here, we're looking for the height of the cone, so we're looking for that perpendicular distance from the top to the bottom. Okay, all right, so now let's find the volume of this cone. So my volume would be 1/3 big BH. So over here, I'm going to find my big B. That's the area of my base. In this case, it's a circle, so it'd be pi r squared. So my radius is 2.2, so it'd be pi times 2.2 squared, because that's my radius right there. So I'm going to take 2.2 and square it. I get 4.84, so I'd have 4.84, that's not rounding, pi, 4.84 pi. So that's the area of my base, my big B. So I need to take 1/3 big B, which we can put that in. It would be 4.84 pi times the height, my straight up and down height from top to bottom they give me here is 4.5. Okay. So now I'm going to multiply the 1/3 times the 4.84 times the 4.5 and then multiply it times pi. But I'm not going to round. I'm just going to type in my calculator. 1/3 times the 4.84 times the 4.5, and I get 7.26. It's not rounding at all, so it'd be 7.26 pi. Or if I get that as a fraction, math enter, 363 over 50 pi. So either one of those will work. My units here, it's volume, so that's cubic units, so centimeters cubed. Or then let's approximate, so I'll take that 363 times 50, multiply it by pi, which is approximately 22.81. Oh wait, we only have, well, one decimal place, so we'll just go to the one decimal place here as well, and that would be centimeters cubed. So probably this one is probably the prettiest exact answer, and this one is the prettiest approximate, 22.8 cubic centimeters. Okay. All right, last one. Cone A and cone B are similar. We want to find the volume of cone B. So first of all, I know they're similar, which means I can find their scale factor. So let's see if we can't just find their scale factor. Again, this is going to be the linear scale factor. This one's got a radius, the small one's got a radius of 3, the big one's got a radius of 9, both feet. So the scale factor will go 3 feet to 9 feet, which simplifies into 1/3. So my scale factor here is 1 to 3. Okay. So that's my linear scale factor. So my volume scale factor, so the scale factor of the volumes would be that cubed. So I'd have to take the 1/3 and cube it. So that should be the scale factor of the volumes. 1 cubed, 1 times 1 times 1 is 1. 3 cubed, 3 times 3 times 3 is 27. So the ratio of my volumes, if I do small to big, is 1 to 27. So we want to find the volume of cone B. We know the volume of cone A. It's 15 pi, feet cubed. We want to try to find the volume of the bigger cone, so let's let that be x. Okay, so if I go small to big, it should be 1 over 27. So small is 15 pi all over x. So now I'm going to use means extremes, cross multiply. 1 times x, that's just x. I need to take 27 times 15 pi. 27 times 15 is 405. So that would be 405 pi cubic, feet. I was labeling centimeters, cubic feet. And they leave this volume in terms of pi, so I should leave this one over here in terms of pi. So we'll leave it as 405 pi cubic feet. For reference, we can go ahead and do the approximately. It's 1,272.3 cubic